the Agile thing. And also, there'll be some stuff that hopefully you'll have heard in other people's presentations that I think seem to be a theme across all of this. Anyway, so the Agile Connection. So I looked on Wikipedia to see what the heck this Agile thing was, and the four bullets there come from the Agile Manifesto on there. So individuals and interactions over processes and tools. So yeah, we need to use processes and tools a lot in our game, but some of the stuff that jumped out at me was co-locate teams, and that's, I think, really important and complete fantasy in the modern world, sadly. But if you can sit next to verification engineers, if you are within talking distance, and the software engineers will be writing the drivers to work your chips, it is so much better. The benefits are huge. Modern tools like Bugzilla and so on and so forth are great, but they don't really solve the root of the problem. Talking to people is always going to work best. Working software over comprehensive documentation. Well, again, I believe we need documentation, but to kind of to use that, I think with the intent is that as you release RTL functionality with test-driven development, which I'll talk about in a moment, you can make the documentation part of each release as well. So without getting hung up doing a massive document to start with and then jumping into a massive design phase, you can interweave them a lot more. Customer collaboration, yeah, review specs and properties with customers. Our customers, the software engineers, the hardware engineers, your block interacts with architects. So yeah, keep talking with them rather than just being pedantic about the spec. And respond to change. So you can do that in the RTL phase. It's a bit tougher once you release a netlist. It all gets a lot more expensive. But during the RTL phase, up to netlist release, this is all quite feasible. Doing incremental development, documentation changes regularly, but you still need an upfront plan. That's it. You get the impression sometimes from this Agile stuff that people make it up as they go along, and that would be a disaster. That is a disaster for software, I think, as well as, and it certainly would be for us. You do need an upfront plan as a framework to work with, and good communication processes between us all the time, which is the first thing. Co-locating teams will always help. Okay, so let's get on into a little bit more detail. This, for me, is the really interesting bit and the stuff that really delivers. So, test-driven development. I came across this in a Python course as well that kind of formalized for me what it all meant, and realized that we do this and can do it much more in the ASIC world. So the Agile folks kind of split testing up into unit tests, acceptance tests, and integration tests. And I interpret that as unit tests to what designers write as they go along. And for me, that is properties. You basically have a unit, so you've got your block, a typical block a designer will own. It'll be consisting of a whole bunch of sub-blocks, and you do each block as you go along, delivering a particular piece of functionality. First thing you do, you know what this block needs to do, whether it's a FIFO, crossing a clock domain and doing a couple of other checks. Write the properties associated with that block first. Then once you've written those, and I mean system verilog, that's asserts, yeah? And once you've written them, then code the unit. Then you can, the units are the sub-blocks, I've mentioned that, and these are done by the designer, and they're written as part of each incremental release. So if you can release the functionality a small amount at a time to the verification team, if they're ready, then that's great, or just release it for wider, just release it as part of your normal design process, depending on what you interpret by release. Just do that incrementally with each piece of distinct functionality and just build up your design. I'll talk about that in a minute. But the main thing is you write the properties for each block as you go along. Then acceptance tests, there'll be block level simulations. So you might, for example, have two pipelines in your design. Maybe one's transmitting stuff, one's receiving stuff. So maybe you work on the transmit side, and then the block level guys can run their simulations on that. But you're pretty damn confident because you've proven the properties you've written as you go along. And acceptance tests will typically be, that's where the constrained random will come in. They'll be done by a verification engineer. For us, we do a lot of block level simulations. That's our meat and potatoes verification. Integration tests, they're at ASIC level simulations. They're the big beasts that take enormous lengths of time to run, and they're usually constrained random these days as well, and they'll be done by separate verification engineers also. But test-driven development thing is really good. So that's what I'm going to talk about a little bit more. So did I go the wrong way then? Okay, formal in the design process. Sorry, no, I didn't. So what does it look like? So for each of these sub-blocks, we're going to write the properties. You really want to think about how you write your properties. I'll show you some examples in a moment, particularly about naming them. So as an example, you might, operations that your block initiates, call them all master, something or other. Things that come in and operate on us, so stimulate us from the outside, call them slave perhaps, because we're the slave in that respect. So everything's named master star or slave star. And then in terms of making this practical and so you can prove it within your tool, the slave operations, the ones that are coming into the outside from the outside, those you will turn into assumes with something like the Jasper Gold tool, for example. You assume minus from assert in TCL, and that is essentially your test bench with a bit of tickle to compiler design. And I'll show you an example again in a minute. You can write scoreboards as well if your tool vendor supports that sort of thing for proving data paths. They're very useful. CDC, checking there's some level of that available also with some tools. The example I've got there is from Jasper Gold. So that's really useful for skipping about either side, choosing which clock actually sees data changing. And then as you go along, you add other sub-blocks and increase the scope of the properties. And the assumes, with the assume from assert, are kind of done on the outside, on the boundary of where you've got to. Where's the pointer on this, Mike? Is it the start thing, I suppose? Ah, there we go. So if we imagine we've got our big block with all these sub-blocks inside, to start with, you just do this block F, and the boundary of that, the properties that essentially are owned by blocks surrounding it, you turn into assumes. And then when you do block D, you increase the scope of that boundary. So these what were assumes between D and F, and now they revert to being asserts. So you just leave them as asserts, you don't change them. So you increase the scope of this as you go along, and that works really well. It's really practical, and the really cool thing is there's so little code you have to write to do that. So and that for me works great, and the coverage you get if you build up your design, and if you can organize it such that these are specific pieces of functionality, which of course they usually are, and not massively coupled, which would be a bad approach anyway, then it just works great. So this is what some of this might look like. So we've got typical clocking blocks up here, and maybe default disables. And then we'll have the grouping of the properties. This is system Verilog assertions, obviously. So here I was talking about having consistent names so you can write regular expressions. So we've got CSR master, so this is a control states register block. It's a nice, easy one. So some master, whoever's the master of this bus, there'll be some properties defining how that should behave. And then whoever's the slave on the bus, there'll be some properties defining how that should behave. We'll probably have some coverage properties as well. And then at the bottom in the tickle, depending on whether you're a master or a slave, your particular block, you'll do something like assume from assert star dot CSR master dot star minus regex, something like that. So you can actually very easily, in one fell swoop, create your test bench from all these properties in this manner. Okay, so that was how using properties in the design process works. Property organization. I'm going to have to speed up, I'm afraid, a bit here. So there's kind of three obvious places you can put properties: at the end of the RTL files. So typically at the end of if you have one module, one system Verilog module per file, then at the end of that, you can have them in separate dedicated modules, or you can put them within files, within processes. So we'll just have a quick look at each of those. Properties at the end of the file, that's the most normal place I think we see them done. So you write a module, you write a bunch of properties at the end. Look very similar to what we had on an earlier slide. Typically, obviously, have if and def synthesis around it, so you don't get inundated with warnings. Insight in dedicated modules looks very similar. The really nice thing about System Verilog is you have this bind statement, so you can bind this property module wherever you want, and that's really good if you've got separate modules of properties for interfaces. That's the absolutely classic way you do it. So you have a whole bunch of asserts for a particular interface, and all the blocks that implement that would just bind it onto the interface themselves. So in each of the block level test benches, they do all of that, and it would still be, all those binds would still be there at high level ASIC level simulation as well. Can do it in processes as well. We don't favour that too much ourselves because it creates a lot of noise in the code if you do it buried inline in the actual synthesizable RTL. But sometimes it's really useful if you have the state machine, for example, and inside a case statement. You'd have to reproduce that state machine with helper code elsewhere if you didn't have these sorts of properties buried inside the state machine. So that's the sort of occasion we might do that. Simulation benefits. So this is a big win as well as the actual in the design process doing test-driven development. Simulation benefits thereafter are not to be underestimated. So they're there for, the properties are there for all the simulation. You won't get your Jasper scoreboards, but you'll get all the rest of the properties. And it massively speeds up defect tracking. This is something Harry Foster and folks were on about a decade and a half ago, but it really, really does, because it highlights defects straight away where they occur, buried in the middle of your design as soon as they occur, and well before the actual E-code or your simulation code notices that there's a defect. IP integration. So I don't know about you, but IP we get is rarely perfectly specified. There's often ambiguities in it, you're not quite sure how it works, or when you're designing to interface with that IP, write those assumptions down as properties, so they'll ping off and fail as soon in simulations if those assumptions are wrong. That's really valuable. Test bench development. There's been a lot of talk about the number of defects in people's test benches, and there are. And having the properties really helps on that. So design assumptions are captured by the properties. Verification engineers come around and say, this assert's gone off. What's wrong? Well, it's quite often, and to be honest with you, most of the time, it's a test defect. Software usage. So you can capture the usage. Usually you have software registers that can only be configuration registers that are only sensible with certain combinations of values. So you can capture them in properties as well. And that, again, helps to make sure that the simulations are set up sensibly, so you can constrain system usage. And you can check your verification engineers are actually writing the tests using the data sensibly. And like most things, if you do it as you go along, it's an awful lot easier to revisit it later. And it'll be much more comprehensive. So in a recent block I did, I had 350 properties, some of them in loops. So this is just properties as I wrote as I went along, and we ended up with well over 1,000 properties basically available there, and they're just there all the time in the code every time it's simulated. So finally then, incremental development. This is just talking about the Agile thing again. From the Agile manifesto, you should kind of do all checks continuously with every micro release. I was talking about trying to release small pieces of functionality from your block regularly. And at each release, just try. This is what we're aspiring to, by the way. We don't necessarily quite do this all yet. But at each release, do everything. Obviously, regression test everything you've got, all your assertions, whatever simulations there are available. Do them yourself. We run our own simulations as designers before we release. Synthesize it. Why wouldn't you synthesize it? Why wouldn't you check the RTL gates equivalents? It should be push-button exercises if you've got enough written scripts. Obviously, most people do linting. That's very normal to be part of the process before you release anything. And documentation. Make sure your documentation's up to date. I've always got a LibreOffice version of my spec open all the time, so you can modify it as you go along. There and then should be part of the design process, and it works well with this Agile thing of of keeping everything incremental, and it allows you to be more flexible when you do that. And yeah, maybe if you can persuade anyone to review documentation, design reviews, code reviews as you go along, that's always going to work well. There's a URL that has some interesting things which I've pulled from here. So this agilesoc.com is well worth a look at. So that hopefully this is less cracking. So to summarise then, formal and agile can help you design quality and can design it right. And I've often worried that there's a huge effort goes into trying to testing quality, and that's never going to be as successful. So this agile process thing can be applied to the RTL development, and often we're already doing it. Test-driven development really works. That's for me the big winner. Use properties as your unit tests. It really does work, and the overhead of test benches is so small, it's just a tickle to convert your certs into assumes. Simulation benefits, we talked about that just a moment ago. They're there all the time, and they really help accelerate test bench development as well. And the incremental development thing really works. It delivers features as you go along to the verification team, and without any real numbers, it just feels to us like it works better than anything we've done before. And you can tie it in with all these other checks that you might do, synthesis, CDC checks, and so on. And I could update that documentation all the time. Just keep that spec open all the time for your block. And I'm going to get told off if I go along anymore. But that's it, I think, anyway.
Thank you, John. Thank you. And I think you invented the new term, formal. That's formal agile. You'll see that in the marketing literature quite soon, I think. Any questions for John? Ashish? Yeah, I'm right there.
Hey, quick question. You said acceptance testing and integration testing could use constraint random. What would be the value add of using constraint random for integration testing? Would you not just use direct testing or some?
That's just what I get. So I kind of agree with you because there's quite a big investment in doing that. So that happens to be the way our verification team work at the moment. You do, if you can pull it off, particularly if you can pull off the hard stuff I was talking about this morning with error injection and recovering from that. For me, the real benefit of random is the stuff you hadn't really thought about. Yeah, that's, for me, the stuff outside the test plans, the stuff you hadn't put in a test plan. That's where random helps. But I think underlying what you're saying is it's really expensive to do it at the ASIC level, and I couldn't agree more.
Okay. Okay, thank you very much, John. Oh, no, sorry, one more question. Sorry, Andy. You just...
when you put so many assertions into modules, you mentioned sort of 70K gate. Sometimes by the time you get onto network and chip and big GPU or CPU checks, does it scale in terms of performance at top-level simulation? If you want to run realistic tests at top level, they sometimes run for hours anyway, with 500,000 assertions embedded. Does it scale?
I don't have any numbers from you. I just know that there's always... I don't know. You'd have to probably... I don't have any numbers on that, but all I know is the debug cycles, which everyone's talked about, are huge, and having assertions to help you pinpoint where an error is so much here is the really big saving. So personally, if you've got big sims that take a long time, you set them up, whether they take 30 minutes or an hour, because you've got so many properties in there. If it's 30 minutes, I'm off doing something else anyway. I probably won't go back to it for another couple of hours anyway. Yeah, because that feels the way things work to me. So I agree with you. It can only slow stuff down. There's more checks to be made. But I'd like to think it speeds up the human time you spend on actually debugging things.
Okay. Thanks, Andy. Thanks, John. Thank you.